Good day, grade 12s. Great to see you again. As I said, our lessons are going to be a little bit more difficult from now on. So you need to really every day, just every day, make sure you know what's going on. Okay, so let's have a look. Today is 28 January, and you write for me on top. Now we are talking about arithmetic series. So we are talking about series there, and instead of sequences. So series means that it is the sum of a sequence. So in the same way you get an arithmetic sequence, you get an arithmetic series. So an arithmetic series would be the sum of the terms in an arithmetic sequence. So firstly, what we are going to do is we have to prove the formula for the sum of an arithmetic series. But before we do that, we are going to just do an example in real numbers so that you can see how the system works. So let's have a look. So this is also in your text. Okay, so I've got 3 plus 7 plus 11 plus 15 plus 19 plus 23. So this is my arithmetic sequence. So this is my first term. This is my last term. So we can see that the differences are 4 now. So the differences are 4 and the A is a 3. But now the proof that we are going to do is this. We are going to say, so there are 1, 2, 3, 4, 5, 6 terms. So the symbol that we use is S of 6 or S of N for N terms. So we have 6 terms, the sum of 6 terms. So let's write down the sum of 6 terms. 3 plus 7 plus 11 plus 15 plus 19 plus 23. And now we write it again, but we start at the beginning. So we say 3 plus 7 plus 11 plus 15 plus 19 plus 23. And when we add these two sums, then we get 2 times S6. Okay, and look what we get. We get 26 plus 26 plus 26. So for all 6 terms, we get 26. So it's going to look like this. 2 times the sum of 6 is 6 times 26. Okay. And just the S then of 6 numbers, this is a 6, is 6 over 2, 6 divided by this 2 times 26. So in general, we say the sum of n terms is, because the 6 is the number of terms that we add together. So it's going to be n over 2, and the 26 is term 1 plus the last term, term 1. So the last term we can write as L. First term is A, last term is L. Okay, so let's have a look at this just very quickly, just something else that I need to show you. If I write the sum of the first n terms, I'm having A plus D plus A plus 2D. So it is term 1 plus term 2 plus term 3. And so we go on until we get term n. So A plus n minus 1D, we know that Tn is A plus n minus 1D. Okay, so this is what the sum looks like. Now, Tn is the last term, and that last term we also call L. Okay? Now, let's have a look at our sequence again. Just move this up a bit. So I've got Sn equals A plus D, and the D is the difference, plus A plus 2D. So this is term 1, term 2, term 3. Difference is in D. So if we write the last term that we had here, A plus N minus 1D, if we write the last term as an L, and the difference is a D, then the second last term will be L minus D. Now, L minus D gives me this term here. And the third one, last one, would be L minus 2D. But just to give that under our understanding, that one there. So, now, this is the proof. So, it's an examinable proof. They will ask you this. Prove that the sum for the first n numbers of an arithmetic sequence is n over 2 square bracket 2a plus n minus 1 d. And this you have to know. You do get it at the end of the year, but if you don't know your formulas, you will not be able to manipulate or understand how the sums work. So know the formulas so that you work with it much easier. So let's have a look then at our sequence. So I've got Sn equals A plus D plus A plus 2D plus dot plus. So the last term is L, the second last is L minus D, as we just saw. Now, we're going to write the same sequence, but we start at the back. So the A we write under the L, A plus D plus dot, and the L is the last term. So in this case, it's the first term, plus L minus D plus L minus 2D. And now I add it again. So I say Sn plus Sn is 2Sn. So if I add the A and the L, I get A plus L. This one, A plus D, L minus D, I get A plus L. A plus 2D, L minus 2D, A plus L. And so it goes up until the last term. So I can say that 2 times Sn is equal to, there are n terms, so it's n times A plus L. N times A plus L. Then we say but Tn, the general term of a arithmetic sequence, is Tn equals A plus N minus 1D. Okay? And the Tn is also the L. You remember we said here, the last term is called Tn because it's the nth term, and we name the nth term L. So the formula for Tn is A plus N minus 1D. So that is also the formula for the L. So if I look at the formula for Tn, A plus N minus 1D, and it's also the L, right? So A plus L is then A plus A, so that gives me 2A plus N minus 1D. So there's where 2A comes from. This A plus that A there. So that means that, so I'll go from here, 2Sn equals N plus, this is a 2A plus N minus 1D. It didn't quite fit in there. So 2 times the sum. Okay, and now my Sn equals n over 2, because I'm dividing by this 2 here, a plus 2a plus n minus 1d. And that is then the formula they asked us to prove. I want you to go through this whole explanation again. So this, you must be able to write down exactly like it basically. There's no other way to write it down really. So you will get in the exam a question like this. It will probably be about 6 marks, and this is how you are going to prove it. I'm going to do the work examples that is in your book, number 3. Let's just first look at your books on page 11. Work example 1, determine the sum of the arithmetic series 4 plus 11 plus 12 plus 368. So we know the formula for the sum, and we have our first term and we have our last term. So that means we are going to use this formula, n over 2a plus l, which is the one that we had here before we broke it down to 2a plus n minus 1d, right? But if we look at this series, we don't know. We want to use this formula, right? We don't have the n. So we first need to find the n before we can substitute it into the sum. So we are going to find the n by substituting 368 here where t is. Then we will be able to find the n, and then we are going to substitute the n into this formula here. You may substitute it into this formula, no problem. It's just a longer process. If you look at work example 2, determine the sum of the first 20 terms. So here we know what the n is of Sn. We have the first term, minus 15. We have the difference. So basically, my one formula, I have the n, which is 20. I have the a, which is minus 15. I have the d, which is plus 6. Substitute, and I get an answer. This page, this line here is not applicable to this sum. I think it's one of the sums here at the bottom. So that line, you could just draw a line through that written line. Okay, so let's have a look at work example 3. So for work example 3, we need this. Okay, so this is a lot to cover today. You'll have to go through this material again. Let's just look at Sn. Sn, the sum of the first n terms. It is T1 plus T2 plus T3 plus Tn minus 1 plus Tn. Right, that's straightforward. Next. Second last term, last term. Now, if I take the sum of the first n minus 1 numbers, so there's T1 plus T2 plus T3, goes on and on and on, plus, there must be pluses, Tn minus 1. So we stop at Tn minus 1 because it's the sum of the first n minus 1 terms. So now, if I say I take the top line minus the bottom line, then you can see the only one that's left over that isn't cancelled out is Tn. So if I want to get Tn, then I'm going to take Sn minus Sn minus 1. So what does that mean? It means that I can say term 10 equals the sum of the first 10 minus the sum of 9 numbers, right? Or term 12 is the sum of 12 terms minus the sum of 11 terms. This is really important because this is the more difficult questions in the exam is around this system here, the way that you determine a term given the formula for the sum, right? So let's have a look now at the question. So if we look at work example 3 here, they give us Sn equals 2n squared plus 9n. Determine the first 3 terms of the sequence. Now remember that this is not Tn, this is Sn. So if we look at S1, S1 is most the sum of the first 1 term. So S1 equals to T1, right? So S1 is just T1 is S1. So we substitute it into this formula, 2n squared plus 9. We substitute 1 into that, and we get that T1 is 11. Then we are going to work out T2. So T2 we know is S2 minus S1. So S2, I'm going to substitute into this formula, right? Then I'm going to say S2 minus, so it's going, this is 26, the sum is 26. The first term is 11, so what's going to be left is term 2, which is 50. Term 3 is going to be sum of the first 3 numbers minus sum of the first 2 numbers. So that is, if I substitute into this Sn formula, I get 45. So the sum of the first 3 terms, 45. The sum of the first 2 terms, 26. So term 3 is 19. And these the first 3 terms of my sequence or my series. Doesn't really matter which one. So now the question is, now we have to look very closely to what they say, because number 2 is determined the 12th term, and number 3 is determined the 12th term. So they want T12, right? So number 2 says by using the formula, by using this formula here, determine T12. So this is what we have been doing all along. So we say term 12 is sum of 12 minus sum of 11. So here we substitute sum of 12. Oh, there I minus 9. I squashed it in too much. 9 of 11. Okay? And that gives me 55. So T12 is 55. So there I worked it out using the formula for the sum. Now they say determine the 12th term by determining the formula of the 12th term. So that means determining Tn. That's what they're looking for. So the nth term is Tn. And we know that Tn is a plus, I write the d in front, n minus 1. So if I look at my numbers here, a is 11 and the d is 4. So Tn is then 11 plus 4 times n minus 1. When I simplify it, I get Tn equals 4n plus 7. And then I substitute T12, and I get that T12 is 55, And that is exactly what we had here in question 2. Still another one, work example 4. So okay, do you remember when we worked with arithmetic sequences? We had simultaneous equations when they give you a type of sum like this. And in this case, it's the same, the equations just looks differently. So the second term is 17. So I'm writing here for myself, T2 is 17. And they say the sum of the first 6 terms is 147. So S6 is 147. So now we're going to write the formulas. So for T2, my formula, just get my ruler here. The formula for T2 is was A plus T. So here, I can write any one of the two. So I decided to use the A. So A is 17 minus D, and that is my first equation. Then I write the formula for S of 6. So it's 147 equals, so it was N over 2, so it's 6 over 2, 2A plus D, 6 minus D. And now I substitute number 1 in there. So I'm going to say 145, 6 over 2 is 3, right? So this 6 over 2 is that 3 there. So it's 2 times A, so this is my A, plus, and D times 6 minus 1, because it's D in minus 1. So it's 5D. 147 equals, so this is minus 2D plus 5D, and this is what I end up with. And I can solve D equals 5. I can say this is number 2 or number 3 as you wish, and then substitute 2 into 1 to get the A. So the A is 12, and that means I've got the D and I've got the A. So the A is 12, 12 plus 5, 12, 17 plus 5. So that's the first 3 terms. That is the question they are asking us. And this, then they ask us the T of N, the formula. So we are just substituting it, A plus D n minus 1. So we get Tn equals, so 4n plus 12 minus 4 gives me plus 7. Here we go. Okay, for homework, I'm giving you exercise 5. Now, this lesson, there's a lot of information in this lesson. And this lesson is worth about 12 to 15 marks. So you really, this lesson, mark it with a big star. This is an important lesson. People enjoy this. I think it's nice to do a bit of work that asks of you to think a bit further than what you have been told. Enjoy.